Okay, let's do 2.6. 2.6 is on Cartesian products. Okay. So an ordered pair, xy, has a value that represents x and a value that represents y. Okay. Unlike sets with braces, order matters with an ordered pair. Order matters. The Cartesian product A cross B is the set of all ordered pairs where the first entry in the set is A and the second entry in the set is B. Oh, sorry. This should say where the first entry is in set A. And the second entry is in set B. So A cross B is equal to little b, ordered pair, such that A is an element of set A and B, little b, is an element of set B. Oops. There we go. The cardinality or how many elements can be in A could be represented by AB is just the multiplication of the two sets. The cardinality of A cross B is equal to the cardinality of A times the cardinality of B. Okay, example 1. Okay, find A cross B and B cross A, which they are not the same thing, if A is set 1, 2, and B is set A, B, C. So let's first find okay, A cross B. Okay, so for A cross B, okay, we're going to match each of them. Okay, we would say, okay, if I have set A here, 1, 2, and set B as A, B, C, then the points or the ordered pairs okay, The ordered pairs here, they are going to be 1A, 2A, yeah, 1B, 2B, okay, 1C, 2C. Okay. We say A cross B is the set of ordered pairs 1A, 2A, or sorry, 1B, so it's in order, 1B, 1C, 2A, 2B, 2C. Okay, and notice that the cardinality for A is 2, the cardinality for B is 3, and the cardinality of A cross B is 6, or 2 times 3. Okay. For B cross A, we would have B, A, B, C, and then A, 1, 2. Okay, and this would be A1. This would be A2. This would be B1, B2. This would be C1, C2. Oops. C2. Okay, so we would get B cross A is, okay, A1, A2, B1, B2, okay, C1, C2. And again, we have six elements, 6 ordered pairs. Okay. Okay, the set Z cross Z forms an infinite grid of points called the Cartesian coordinate system. Okay, X, Y. Okay, so if we look at our Cartesian coordinate system, we could have 1, 2. We could have 1, 2. We could have -1, -2. And this is just this coordinate system that you're used to. -1, negative. And so every point here okay, is a part of this grid. Okay, and it's the Cartesian coordinate system. So for example, this point here is at 2, 2. This point here is at 2, 1, 2, 0, 2, -1, 2, -2. Okay, you can label any other points that way as well. Okay, an ordered list of 3 items is called an ordered triple. Okay, X, Y, Z. If anybody's taken Calc 3, we use this a lot. Okay. For n greater than or equal to 4, an ordered list of n items is called an n tuple. Okay, an n tuple. The Cartesian product of n sets A1, A2, A3 to AN. Okay, so the Cartesian product of that thing is A1 cross A2 cross A3 cross dot 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 cross AN okay, is equal to A1, A2 dot 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 AN A such that AI is an element of set AI for all I, okay, from I going from 1 to n. Okay, so if we generalize this, we're just going to get n tuples, which will be of order n. Okay. Move that up. Okay, if we take A cross B cross C cross D, that creates a four tuple Okay, 4 tuples, and we can let that be X, Y, Z, and W. Okay, the Cartesian product of a set with itself okay, as A cross A, we're going to call that A squared. Okay, or more generally, okay, A cross A cross A cross dot 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 n times okay, is A to the nth power. Okay, for A equals 0 and 1. So we just have 0, 1 in our sets. Okay, then A squared is gonna look like what? Well, it's gonna have ordered pairs of magnitude 2. So this will be a complete set of 0, 0, 0, 1, 1, 0, and 1, 1. All the possible ordered pairs, okay, that we could possibly come up with the elements being just 0 and 1. Okay. A cubed is going to be equal to, okay, a set of 8 elements. So it's 2 to the third power. Okay. So think of the A as the elements. They're two elements. A squared is going to be 2 to the second. A cubed is going to be 2 to the third. Okay. So this is going to be 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, and 1, 1, 1. Okay. Where this comes in handy is when we start thinking in terms of number sets. Okay, like real numbers, integers, natural numbers. Okay. So R cross R is equal to R squared, okay, is the set of all real numbers x, y, such that x and y are real numbers. Okay. Okay, it's a set of all ordered pairs Okay. Maybe I'll change that to ordered pairs. Set of all ordered pairs x, y kind of makes more sense. Such that x and y are real numbers. Okay. R3 is the set x, y, z, okay, where x, y, and z are elements of R. Okay, and I'll put it like this. Okay. Okay, let's talk about strings here. These strings. So a string, okay, if A is a set of symbols and, or sorry, a set of them or characteristics or characters, then A to the nth power can be written as a sequence of characters called a string. Okay. If A is equal to the set containing A and B, then we could say that A squared is equal to all possible strings of length 2 using the elements A and B. So AA, AB, BA, and BB. Okay, and the set of characters used, okay, in this case, A and B, is called the alphabet for the strings. Okay, the strings in A2 are AA, AB, BA, BB, and its alphabet is the original set AB. Okay, the string length is the number of characters in the string. In the string. Okay. Okay, a binary string is a string whose alphabet is 0, 1. Okay, so we just use the character 0, 1 as our alphabet. Okay, those are the values in our set that we're using. A bit is a character in the binary string. A binary string okay, is called an n-bit string and is an element of 0, 1 to the nth power. Okay. So think of, like if a is equal to 0, 1, then a to the nth power, okay, is 0, 1 to the nth power. If I have a squared here, okay, or 0, 1 squared, we really don't need the a anymore. We can just look at the string and we can look at the alphabet and then square it. Then, what does this become? This becomes all of the values, all of the strings that I can create with these two. Okay, with these two characters, and each of those has how many bits in the string? Well, they're all 2-bit strings. Okay. Okay, and we could do n-bit strings. Okay. The string, okay, 0, 0, 1, 0, 1, 1, 0 is an example of a 7-bit string and is an element of 0, 1 to the 7th power. Okay, the empty string okay, is the unique string whose length is 0. Unique string whose length is 0. Okay. It is denoted by the Greek letter lambda. Okay, that's lambda. Okay, and so we could say that 0, 1, to set 0, 1 to the 0th power is replaced by the Greek letter lambda. It just means that it's basically the null string. Okay, concatenation is the process of putting two strings together For example, if S is equal to 0, 1, 0, and T is equal to 1, 1, then ST is equal to 0, 1, 0, 1, 1. Okay, we just put them side by side. Example 2. Okay, list all strings for X, Y, where X is an element of ABC, and Y is an element of AB, little ab squared. Okay, list all strings X, Y, putting X and Y together, where X is an element of A, B, C, and Y is an element of AB squared. Well, first we need to figure out, well, what's AB squared? Well, AB squared is going to be AA, AB, BA, and BB. Okay, so that's AB squared. So now we want to concatenate X with Y, put X and Y together, and all the combinations therein. So what do we have? We have A, big A with little aa, big A with little ab, big A with little ba, and big A with little bb. And then we can do the same thing with the big B. We can do the same thing with the big C. AA, AB, BA, BB, AA, AB, BA, BB. Okay. And that is 2.6.